Let's try another somewhat ugly exponents problem. So what we have here is this beautiful bracket here. This we're called bedmass. We want to generally try to work within here first. I'm going to begin with the numbers. 250 divided by -2. I know what that is. So let's try this without a calculator. 250 divided by 2, half of 250 is going to be 125. So we have -125. And what I'm going to do here is I'm looking, so this is all to the 2/3 by the way. I'm looking at the a's next. We begin with one variable and you move on to the next variable b and move on to the c's. In the same way you can begin with the x's, move on to the y's and the z's, etc. But what we have here is the same base. We have a to the exponent -2 divided by a to the exponent -3. Recall that according to exponent law, when we have the same base using division in this way, we're going to subtract the exponent. So we have a to the -2 subtract -3. So minus subtract the bottom, which is -3. Now this is tricky because two negatives make a positive, and that's a very common error. So please be careful. So we have b to the 3. It's going to be this same base, 3 subtract minus the 7 here, all to the 2/3. So let's focus on this number 125. This -125 looks a bit suspicious. 5 times 5 times 5 is 125. So hopefully you'll see that. And the trick here, so let me just leave this as 2/3. The trick here is to try rewriting that number with brackets around it. So in this case it'd be -5 cubed. -5 times -5 times -5 indeed is -125. So we have a to the -2 plus 3 would be a to the 1. I'm not going to bother writing that. B to the 3 minus 7 is -4. So what happens next? This is where we spread the exponent love. This exponent gives the number some love, as well as the variable a, as well as variable b. Exponent bracket, this thick rectangular bracket, exponent bracket exponent means we multiply. So let's write this number part first. Don't forget, common error is that people always forget to spread the love, the exponent love, to the number itself. So this is going to be 5 to the 3 times 2/3, because we're multiplying. And then we're spreading the exponent love to the variable a. So this is a to the 1 times 2/3. And then we have b. b to the -4, and this exponent is going to be multiplied times 2/3. So what we end up with is 3 times 2/3. The 3's cancel out. We get just the answer is 2. So this here is equals to -5 squared, and anything times 1 is itself. So this is a to the 2/3, and b to the, this becomes -4 times 2 is 8, -8/3. And if the question was to specify that they want exponents left as a fraction, we'll just leave this alone. And if they're asking for a positive fraction, so imagine the question is asking for positive fractions, then we're going to put this number, the b, to the bottom, because when we move the from the numerator to the denominator, the sign of the exponent switches. So the -8/3 becomes 8/3, whereas the a to the 2/3 stays on the top, and -5 times -5 is 25. For exponent questions, it's expected that you just work out the numbers. So instead of writing 2 to the 3, for example, I would write 8. In the same way, -5 times -5 is 25. It's better to rewrite it as 25 rather than leave it in this form. So here's our final answer. So for these exponent problems, there's more than one way to do things. So as long as you have your consistent technique, don't confuse the idea of exponent bracket exponent is multiplied versus adding. So make sure we multiply these. And you're really careful with the idea of having the same base and you're subtracting. Subtract a negative becomes a positive. So just be really careful with that and you should be fine.